Good morning, everyone. If you're joining us, you are currently in the webinar for the Chameleon tutorial for EuroSys artifact evaluation. So hopefully everyone's in the right place. And my apologies for getting started a little late here. I'm just going to give other attendees another couple minutes to join, and then we will go ahead and get started with a short presentation on Chameleon, after which we will go ahead and open up the floor for more questions from any of the folks who are here with us today. And this is a good opportunity to get in any questions, find other features on Chameleon that you may not know have existed and can potentially help you with your artifact evaluation. I see we have Bogdan Stoika on the call. I'm going to see if he wants to say something before we go ahead and get started here.
Yeah, hey everyone. Sorry, I could not connect for some reason. I had to switch to back to my UChicago account. And still I don't have all the features. I don't have a camera, for example. I'm not sure what's going on. And I cannot see the participants, but I'm assuming are folks from the Artifact Evaluation Committee and some of the authors. So,
Yeah, I think it's because I had those webinar settings misconfigured, but I just added you as a panelist, so now you should have the ability to uncloak.
okay. Awesome. Hey everybody. Sorry, I was trying to figure out I'm transitioning from UChicago to UIUC, and that means my accounts are up in the air. Welcome everybody. I'm guessing most of you are part of the Artifact Evaluation Committee. Hopefully we have a bunch of authors as well. This is one of two sessions, two webinars. The next one will be next week. But as Mark was mentioning, this is for you to give. Mark will give us a rundown of Chameleon and Trovy, which are platforms that will allow you to deploy, build, deploy, and evaluate artifacts much more easier than, say, on your own machine. It has historically, EuroSys has been a conference where people submit papers with sometimes funky hardware requirements, and that has been a problem with artifact evaluation in the past. We're very grateful for Chameleon Cloud that is allowing us to use their infrastructure for, and hopefully, we get some of that unusual hardware when needed. The artifact evaluation process, as you know, for EuroSys will actually have two rounds. The current one is the spring, which means the papers that have been submitted during the spring deadline for EuroSys are being evaluated now in August, September. And then there is another deadline in October, so potential authors can submit papers. Prospective authors can submit papers to that deadline, and if they get accepted, their artifacts will be evaluated in February, March. I don't remember the dates, but they're on the website. We're very grateful that you guys have volunteered for the Artifact Evaluation Committee. You will be required, to participate in both sessions unless there's some, conflicts. So if that's the case, please let us know. But the expectation is you guys will participate in both sessions. And we expect one or two artifacts to be assigned to you per session. The authors are still adding in their artifacts. They still have a few more days until I guess Wednesday next week, so a little over a week to add artifacts. If you go on the website, on the spring version of the website, you won't see anything there for now. So, but don't panic. You know, the artifacts are coming. Yeah, and some of you might be familiar with Chameleon, might actually be users. Some of you might be familiar with the Cloud Lab, which is something, which is again an academic cloud that allows you to, reserve or book machines, and compute time and run experiments. But Chameleon has has many more cool features that Mark will walk us through. Yeah, and this will be a session not only for us to talk about what Chameleon is and how can it help you, but also for you to ask questions about the infrastructure, about the conference, about the artifact evaluation process in general. We're more than happy to take questions towards the end. And without further ado, I'll just turn it away to Mark. And yeah, happy to answer questions towards the end.
Okay, thank you, Bogdan. That's very generous introduction. I appreciate the the love for Chameleon. So we are going to do short kind of overview of the platform. Hopefully, I won't talk too long through all that. So I'm gonna try and keep that pretty brief since it's mostly high level stuff. And then I'm gonna kind of focus more on showing how you can get access to hardware and reserve hardware on Chameleon, how you can look for different types of hardware that we have available. And then I'll also spend a little bit of time going through our Trovy service, which is a repository or service for sharing artifacts. And the cool thing about Trovy is it's integrated with the Chameleon testbed. So artifacts that you find on Trovy, you can execute on the Chameleon hardware. And we'll talk a little bit about Python-Chi, which is a software development kit that we make available for programmatic access to the testbed. So you can write a script or a notebook that does everything from, searches for the first available node, finds that node, makes a reservation for it for a specific period of time, and then you can, of course, run workloads on that instance through this Jupyter notebook and get back results and then graph those results in the notebook. So we'll see how all of that kind of plays together and hopefully is of some value to everyone for the artifact evaluation. I'll also mention just briefly at the beginning that we love supporting reproducibility initiatives like this on Chameleon. Kate Cahey, who is the lead PI for Chameleon Project, is a big advocate for reproducibility and transparency in science. You could say Chameleon is somewhat built with reproducibility in mind. So a lot of the things that we try to promote on the platform is in the vein of trying to promote best practices and sharing artifacts and sharing results. So I'm really excited to be here and thank you all for coming. So I'm gonna share my screen now so that we can actually do some fun stuff. Just give me a second here. Okay, so hopefully everyone's able to see my screen clearly. It should just be a PowerPoint. Um, so my name is Mark Richardson. I am technical project manager for the Chameleon testbed. I am been with the team for about 2 years now, and assist with operations, testbed policy, user engagement, outreach. And I work very closely with all of the engineers on our testbed. So one of them is Mark Powers, who isn't here with us right now, but he is one of the engineers. We also have um, Mike Sherman, Paul Marshall, a couple other folks, as well as some staff at TAC and InCar who are all working to support this wonderful project. So all of these folks are staffed on the help desk. So if you reach out to the help desk, you are going to talk to one of those people. Very knowledgeable. They're going to be able to help you as much as they can to get unstuck. So it's always important. I always mention at the very beginning, if later on, if at any point you need any help with any of this stuff, the help desk, help@chameleoncloud.org is the best place to start for getting help quickly. So before we get into what you'll need help with, let's talk about what there is. So Chameleon is an edge to cloud testbed. We offer full bare metal reconfigurability for most of our sites, with the exception of KVM Cloud, which is a more traditional VM cloud that we offer. And then we also have a Chiat Edge testbed, which is mostly container-based, and this is used to run workloads on small edge devices like Raspberry Pis and the more powerful Jets and Nanos. So with this reconfigurability, you get a lot of flexibility and customization. Along with that configurability, we offer a lot of diversity. We have lots of CPU, kind of traditional compute nodes. We have diverse specialized hardware like FPGAs, GPUs, NVDIMMs, different types of storage hardware, along with some of the edge devices. So a lot of diversity. And we do have all of these nodes are networked together. So this is supported over a very fast network, which is also connected to the Fabric testbed network, which if you've ever worked with Fabric, we actually have a lot of users who do experiments that require both Fabric and Chameleon hardware. And they're able to do that because all of our sites are connected over Fabric's network. So what is Chameleon? Mostly it's a kind of a mix of OpenStack and special sauce, quote unquote. So if you're familiar with OpenStack, it is a very popular system for managing resources like a cloud. It's open source, and we've actually contributed to a lot of the libraries in OpenStack, in particular the Blazor library, which is what we use for our reservations. So some of Chameleon might feel a little bit familiar if you've ever worked with OpenStack. I would also say OpenStack documentation is sometimes helpful as well. So if you're stuck and you feel like you're not getting the answer you need from Chameleon, you might try looking at OpenStack briefly to see if there's something there. And then we'll talk more about the digital artifact sharing, but we do have an integrated Jupyter environment that you can use to interact with testbed materials. We have Trovy, which I already mentioned, along with the day pass feature, which is something we provide for sharing Trovy artifacts and then allowing other people to run the artifact on your allocation. Because, right, you can't use Chameleon resources unless you have an allocation. So we'll get into that a little bit more. Here we just have a couple of high level stats that you can see on the screen. This picture is showing the first Chameleon rack, I believe. This is the very first Chameleon rack. And then on the right here, you have the very first Cheat Edge devices. And this is another diagram just kind of showing the layout of the resource. As I mentioned, two main sites, one at UC and TAC. These do have different hardware, so you will see different hardware depending on which site you're using. Very important to be aware of. And then we're also adding a new site at Chiat which is still in the works. We have some other volunteer sites. And I'll go over how to find all this hardware in a second. So the general experiment workflow on Chameleon is starts with resource discovery. So we'll kind of run through all of these little these sections here, but this is just showing the kind of high level overview, resource discovery, allocate your resources, configure your environment, and then run the experiment and analyze the results. I'm going to skip over some of these slides because this is just kind of background context that we don't need to know right now, talking a little bit more about Cheat Edge. Images, so you might be wondering, once I reserve something and then I can launch something on it, what do I actually launch on it? We do have supported images for bare metal nodes, so these include pretty much all of these ones here at the top that are listed. And then we also allow users to upload their own custom images. So users can make these publicly available to the rest of the community. So when you're launching an instance, you might see a whole lot of images that you can potentially use. A lot of these are images that are contributed by users, or, in some cases, they might just be someone else saving their work. But you can, of course, always look through some of those and see if anyone's done anything that maybe is similar to what you're doing and reuse some of their work, so to speak. We also have snapshotting. So this is, again, another important thing for saving work. Chameleon resources are only available for 7-day leases. So you do need to have some kind of data management plan in place when working with Chameleon. Typically, we suggest that people use either one of our persistent storage options and volumes, or sorry, object store, or our shared file system. But you can also kind of save the status of your work by using our snapshot utility, CC snapshot, which will just take a static kind of statically save your image at that moment that you run it, and then you can come back and reboot that image on another instance or at a later time. I'm going to skip over this. So we'll talk a little bit about orchestration when I'm going through more of the demo. I think a lot of this stuff is a lot easier to see, of course, when someone's actually using the platform. Practical reproducibility, I already mentioned, we really support this on the test bed. Our goal is to make it as easy to reproduce a paper as it is to download and read it. So we want to reduce the cost of reproducing research, and a big part of that is finding ways to make it easier for folks to rerun experiments. And that's a big part of what we do at Trovi. Another thing I'll mention quickly at the beginning is we have our reproducibility workshop report that came out in April. This was a report we put together at a meeting during Supercomputing 2025 or 2024. And if you scan the QR code on the screen here, it will take you to the download page. I recommend this just because it has an artifact checklist and other useful suggestions for packaging artifacts that can be helpful as you're working through the process and thinking about what do I need to include and what do I not need to include. It also includes like other stylistic guides, like things you can do to make your reviewer's life easier, things like that. So it's definitely worth checking out. Maybe you're already familiar with a bunch of this stuff, maybe not, but definitely worth taking a look at. I think I'm going to skip through most of the rest of this stuff so we can just get to the actual demo. So I'm going to stop sharing the presentation here, and then I'm going to go ahead and hop over to Chameleon. So probably biggest thing you're going to be thinking about coming to chameleoncloud.org is user accounts. So I'm already logged in here, but if I were to log out and then go back to the site, so this is what you would see logging in the first time, and you're just going to go up here and click this login button. This is going to log me in automatically because I've already been using it, but if you were doing this for the first time, it's going to take you to another page that asks you to log in via federated login. So we use Globus federated login for our authentication. This hopefully makes it easy for all of you to use Chameleon, because hopefully your affiliate institution is part of Globus, and if it is, then basically when you click on that federated login, it's going to take you to a Globus page that's going to tell you, what's your institution. You're going to select your institution, and then you'll be able to log in like you would normally. Hopefully all of that works for you. If it doesn't work for you, we do also offer single sign-on, or sorry, not single sign-on. We also offer login through or authentication through Google, and I believe the other one is GitHub. Yeah. So we do have other alternatives if you can't use the Globus authorization, but that one is highly recommended. Is definitely the smoothest way to get an account and get started. So once you get an account, you're probably going to land on a page that looks like this. This is called the user dashboard page. And the dashboard page is just going to have an overview of your active projects on Chameleon, as well as an overview of your open tickets. So I mentioned the help desk earlier. This is where you can go after you have an account to actually open a ticket and talk about, explain what your issue is. Once you do that, that ticket will show up here, and then you'll be able to follow that ticket history from the dashboard. So just mentioning that as a good way to get help, and this is integrated into the system, so you'll get notifications and such when the tickets are updated. On the project side, so you shouldn't have to worry about this because we've already created projects for this artifact evaluation. So these two projects at the bottom here are the projects that I'm referring to. You should already be added to these or will be added to them shortly. But once you're added to a project, yeah, it looks like nobody's been added yet. But once you're added to this project, you'll then have access to this resource allocation here. And this allocation is measured in what we call service units, which are basically hours of compute time. Actually, for Chameleon, it's based on the reservation time, because bare metal nodes, you reserve them. Even if you're not using them, no one else can use them. So we charge you for them based on reservation. So these are, essentially equivalent to 1 hour of reserved bare metal time. VMs are also charged against the allocation, but at a much reduced rate. GPUs, specialized hardware, are actually charged with a multiplier. So GPUs cost 2 SUs per hour versus a CPU would be 1 SU. We do have all the details about this in our FAQs if you want to go and read more about that. So anyways, you shouldn't have to worry about setting up a project, but you should already be added to an active project on Chameleon. Once you're added to this project, you'll have access to use the resources under the project. And so you'll be able to go and make reservations and do everything that you would normally do on Chameleon. But this is a very important first step. If you're not added to this project, you will not be able to access anything on Chameleon. So just a word of caution there. Do make sure you get added to that project. Once you're added to the project, so we'll go ahead and start walking through that experiment workflow that I mentioned. So once you're in the project, you're going to go and hop over to hardware discovery, probably a good place to start. Maybe you already have a specific type of hardware that you want to use, or maybe you're just kind of open to different options and you want to see what's available. So here you're going to be able to see a very high level overview of all of the resources on Chameleon. Most of the nodes follow this naming convention of kind of general resource type, so compute, and then followed by more specific information about this host. So you can see here we have a bunch of compute nodes, and then we have some GPUs that are available in different types of GPU models. And then these storage nodes here are for either big storage nodes or maybe have more specialized storage hardware attached to them. So you can click on any of these if you're interested in, say, looking at GPU, I don't know, A100, which we only have one of, so there's probably not going to be a lot of availability for that. But GPU, so then if I click on this view more, I can see more details about this node, including what site it's located at, number of CPUs, threads, processor information about the GPU, network, etc. So this is one option to look through the hardware. The other option is to use the filtering. So if you want to just look at, for instance, nodes that are available at in-car, I can see there are these ARM Thunder nodes. If I go and click on UC, again, I'm going to see all the nodes that are available at UC, and so on and so forth. If you want to do something a little bit more sophisticated, we have advanced filters down here. So this has, way more specific information that you can use to filter. And then finally, if you want to just kind of look through the whole list of hardware without clicking any kind of filter, just go down and click View. And here you're going to just be able to look through every node with all the metadata that we provide on the platform. So this can be a good way. You can just, do a quick search and see if you can find something that looks interesting to you. So that's the hardware discovery. Another question you might have is like, okay, so I can see what hardware is available, or I can see what hardware you have on Chameleon, but this doesn't tell me anything about, whether I can reserve this hardware today or tomorrow or next week. So how do we do that? That's going to be something that we'll look at on the individual sites for Chameleon. So I'm going to I'll jump to that shortly. So we're going to come back to this very soon, the hardware availability calendar. But before I jump into the sites, I'm just going to show you quickly the appliance catalog. So this is somewhat similar to the hardware resource, except for appliances, images, heat templates, things like that, folks are either uploading or that are supported by Chameleon staff. probably the most relevant thing is you're going to want to see the Chameleon supported images. So you can click this little checkbox up here, and then you can see all the images that we support and maintain. So these are probably going to be the most stable things to use for your foundation. But you can, of course, browse through all of the other many resources that our users have uploaded as well. So I'll come back to Jupyter interface. Trovy will come back to a little bit later. Cheat Edge is going to be similar to these OpenStack sites. So we'll talk about that a little bit if there's time at the end. But I'm going to go and click onto the Cheat Tax site here. And we're going to go and actually see how we can reserve hardware and look at, launching instances. So if I go to Cheat Tax, this is actually going to take me to a new web domain. So you see here now we're on this chi.tac.chameleon cloud. So this is a Horizon site. It's an OpenStack component for user interfaces. So that's why it looks a little different, but this is also going to be changed depending on what site you're on. So now I switched over to Chi at QC. I'm on a different URL here. So this is what I mean when I say it really matters what site you're on, because what site you're on is going to dictate what resources you see available, what leases you have running, etc. All of that's going to be attached to the site. So very important that you kind of pick a site and make sure you understand, okay, I'm using this site. I need to keep using this site if I want to keep accessing the same stuff. The other thing is you can also select different projects here as well. This shouldn't be an issue for you because we should only be using one project. So there shouldn't be an option to select a different project, but you can choose which project you have active. So just make sure that when you log on to this, you do see that project active at the top here. I don't think you can even get onto this site unless you're on an active project. So that's why I said, if you're not on that project first, you're not going to be able to access anything. You won't even be able to get to this page here. So let's keep going here. So first thing we're going to do is we're going to go down to this reservations tab and we're going to click on leases. So there's not going to be anything here because I haven't made any leases on this. But this is going to be where you do all the reservations for hardware. So the first thing you're going to look at is the host calendar. So I mentioned this is kind of an extension of the resource discovery catalog. But this actually shows you the specific times and specific nodes that are available to reserve. And it's just going to pop up with kind of a NAT chart that shows each of the rows is a host for this particular node type. And then if you see a colored block over this row, that means that the node is currently reserved. Big gray block means that the resource is either in some kind of maintenance state or is potentially failed. And these are also not available. But any node where you see just just white space, this is available on demand. So I can reserve this right now if I want to. I could reserve this one right now. And then looks like there's a couple other ones. So you can also play around and look at different host types. So I can switch over to the GPU M40s. I can see it's one GPU M40 that's available. I can also go ahead and look at Skylake host. So we just looked at that one, and so on and so forth. So this is a really easy way to kind of get a quick overview of what's available and when you can make reservations for certain things. You can also make a reservation in the future. So you could see if you really wanted to use this particular node, you could come see when this reservation is ending and then make a reservation after that reservation so that you have the space after them. So once we've checked the host calendar, we can then come back here and we can say create lease. And this is just going to be a simple form submission. So I'm just going to write some test values here, test lease. I can pick the start date, start time. If I don't pick anything, default is to start immediately. And then I can also tell I can also say how long I want the lease to be in days. And then I can specify a specific end time as well. We'll just keep the defaults. If you're going to reserve hosts, this is where you need to click this checkbox here. You can change the number of hosts that you reserve. And then down here is where you're going to specify what specific resource type you want to reserve. This has actually all of the OpenStack metadata available to it, so you can actually filter by even specific device IDs. If there's like one particular node that you really want to use, you can do that here. But we'll just, say I want to do resource type or node type, compute, and then we'll go next. And then on the next tab, you can reserve a network. This is optional. We really recommend reserving floating IPs in this step because if you don't do this now, you're probably going to have to do it later. You need a floating IP in order to be able to connect to the instance. So I would recommend pretty much doing this all the time. And you can reserve more than one floating IP if you need to. But this is just a good practice to make sure you don't forget that step, and then you don't have to deal with going back and fixing it later. You can also reserve VLANs. So if you want to do that here, you can click this checkbox up here, and then you can specify which resource you want to use for that. And then I can click create here, and it's going to go off and verify that the resource type that I've requested is actually available. If it is available, it's going to go ahead and put the lease on that node so that no one else can have it. And then it's going to come back with this status pending. And that is going to stay at pending until the start of the lease, and then the lease will automatically transfer into the active state. This is not going to show up here immediately, but probably pretty quickly this status is going to change to active because I started the lease, had the lease start immediately. But once we've created the lease, we can click on this lease page here to see more detail about, for instance, the specific resource type, and as well as the floating IP that we've reserved here. And then down here, I can see the specific node that I was allocated for this lease, which is this C1212. Here's the specific UID and the status of the host. So this is kind of the first step. So once I have this lease, this doesn't mean I have actually started running anything on the node. I just have the node reserved. So it's waiting for me. It's ready for me to come and start doing things with it. Once I've at this step, then I'm going to go to instances, and this is where I'm going to launch my instance. And this again is going to be a simple form on the GUI. So you're just going to click launch instance here, give your instance a name, and you can give it a description if you would like. And then another important part is you're going to need to select your lease. So if you don't have a lease, you're not going to be able to do this. You need to have that lease first, and then you're going to select it here. And then here, this is where you're going to tell it how many instances you want to launch. We're just going to do one. On the source page, this is going to be where you actually add your appliance or your image that you want to boot the instance from. So again, we can look up CC images, Chameleon Cloud images. These are the supported images that we talked about. And we can, select, I don't know, something standard like Ubuntu. Use the search better. Yeah, if it has this Chameleon logo, these are the Chameleon images. So just pick like the Ubuntu, I don't know, 22.04. And then here, last kind of important part, or well, second to last important part, we're going to want to allocate a network. I recommend doing shared net because that's going to be basically what allows you to get out to the internet. This is the kind of the standard network. FabNet is more specialized for like if you're doing fancy networking things. And then we're going to go to key pair, and this is where you're going to add a SSH key pair so that you can authenticate to the instance and log and actually connect to it. You can either create a key pair here, or you can just import one that you already have. Or if you have already uploaded a key to Chameleon, it will appear down here, and then you can just add the key to your instance automatically. And then click launch instance. Uh-oh, I got an error. Well, I'm not sure what happens there, but I don't want to waste too much time going back through that whole form. So we'll just pretend that it launched, and now it's basically similar to what we saw down here. It's going to show up as kind of a row in this table. It's going to have the name, some of the metadata information about the instance, and then it will also have the status. And while the instance is booting up, you're going to see the status changing from building to running to etc. This can take quite a while, so we're launching bare metal instances, so these things can take like sometimes 10 to 20 minutes to start up. So be patient. If you don't see your instance like running immediately, it's probably just needs to take some time to get started. So, go take a bathroom break, get some coffee, come back, and probably the instance will be running. And then once the instance is running, you'll be able to see all the details on it, etc. You'll be able to associate your floating IP address with it. And then from there, you'll actually be able to SSH to the instance and start using it for your experiments. So I'll go over some of these other things in here. These are just kind of, all of the data you have associated with your project. If I go to floating IPs, so I mentioned that if you forget to reserve a floating IP, you'll probably need to go ahead and get one anyways. So if you need to go back and get an IP after you've made a reservation, you can come here and click on this allocate IP button here. We do ask that you try to release IPs that you're not using anymore, because we do have a limited pool and bad things happen when we run out of them. So we do ask users to try and come back and release things that you're not using. For instance, I'll go ahead and release this one. So so that we keep the pool full. But anyways, this is a way to kind of ad hoc add resources to your project. There's a bunch of orchestration. This is a lot more advanced stuff using heat templates and things like that. But if you are interested in using any of that stuff, you can check out some of those pages here. I mentioned we have object stores. So this is persistent storage that you can use for saving your work, saving data, etc. And you can add these containers as you need. We also have shares that you can add for storage, sharing data, etc. And that's pretty much everything for the main site. So I'm going to go ahead and switch back over to the main Chameleon Cloud site. And I'm going to go through this Trovy interface, which by talking about Trovy, we'll end up touching on a lot of the Jupyter interface things as well, because Trovy is mostly implemented through the Jupyter interface on Chameleon. But we'll be able to see a lot of the features that are available through there. So if I click on this Trovy tab, it's going to take me to this homepage here. And this is just going to be a big list of artifacts. So these are all artifacts that are available on the Trovy service. These are all mostly Chameleon artifacts, things, GitHub repositories, experiments, notebooks, course materials, pretty much everything you can think of as an artifact was probably on here at some point. Almost all of these are uploaded by our users. We do offer some Chameleon supported artifacts, so these would be these Chameleon badges here. Most of these are kind of what we call experiment templates, so they're like useful getting started guides for people who haven't worked with the platform and maybe aren't as familiar. One of our most popular ones is this bare metal experiment pattern. As you can see, has over 209 launches. Quite a few users have used this notebook here. And that's another cool thing about uploading your stuff to Trovy is if you put it on here, you can actually see kind of the impact that your artifact is having, see how many people are accessing it, how many people are using it. And you can issue versions and update it and so on. So it's very useful for a lot of that sharing, transparency, creating artifacts that other people can then use. So this is a really good potential artifact repository for your artifacts. So if you put together everything and you decide, hey, this could maybe work really well as like a notebook, I really encourage you to consider uploading it to Trovy or creating an artifact on Trovy. And we'll kind of go through how that works. But just to get kind of familiar with what this whole thing is, we'll go ahead and click on this bare metal experiment pattern artifact here. And once we get logged in, we're going to see a little bit of a description about the artifact, who the author is, some contact info, and again, all these stats and stuff that we can see here. Trovy is also integrated with Git, so this makes it super easy for you to upload stuff to Trovy. You can literally just have like a Git repo and follow some of our documentation on how to launch that. And essentially, you just need to include a certain configuration file in the GitHub repository, and then it almost will kind of automatically add it to Trovy for you. I will kind of go through that process a little bit more in detail, so it's not so vague. But if we want to actually launch this artifact, we can click on this Launch on Chameleon button here. We can also just download the artifact if you don't want to, or if you want to look at it first, or you don't want to launch it on Chameleon right away, you can just download it. Again, I mentioned the integration with Git, so you can add this information about where to go to find the experiment on GitHub. But let's say you're interested in running this on Chameleon. Once you click this button, it's going to go ahead and automatically start up a Jupyter environment for you. So this Jupyter, again, if you look up at the URL here, we're on kind of a different site here, Jupyter.Chameleon Cloud. So this environment is kind of running in a certain part of our system, but it gives you access to the rest of your the Chameleon resources, and you'll be able to come here, launch things, create notebooks, create entire repositories of experiments, and still have all of your authentication and access to the test bed and things that you need to be productive. So this environment can be super useful. It also doesn't just include notebooks, but you can also, of course, work with the console. We also have a terminal that you can open up and connect to. And this is going to be in the Jupyter environment, but you can see here at the top, it already has my project identified. So this is really nice environment to work in because it just, a lot of stuff just magically works. And you won't need to kind of worry about configuring a bunch of stuff. But going back to the artifact here, so you see we opened this artifact, and then there were here we can see the folder here for the artifact. And so we click on the folder, we'll go ahead and look at what the artifact actually contains. So first thing we can see is there's a README here. It explains a little bit about the artifacts, the requirements for running it, how much time it's going to take, and then a quick overview of various steps involved. So if I go ahead and click on experiment notebook, I'm going to see a mixture of text and code. So that's one reason we like using notebooks. Can be useful for both providing context as well as the actual code you're using to run your experiment. I mentioned Python Chi library, so this is the Python library that you can use for interacting with Chameleon resources. This is the way to import this library. You don't need to worry about installing it. In this environment, it's already going to be automatically installed, so you can just import it and use it. This is a really useful tool, especially when you're starting to move into working in these different environments. And this notebook is going to be pretty straightforward. So the first thing it's going to do is it's just going to it's just going to choose a default site, and then it's going to ask me to choose a specific project. So again, this shouldn't be an issue for you. You should only have one project, but I'll select this project here. And this is basically now set up. So it's telling me, okay, you're connected to the tax site. This is the specific project you're using. And so we'll be able to proceed like we were working from the web interface itself. Once we get to the hardware availability piece, so kind of notice how everything we just did through the web interface and through these, graphical user interfaces, we're now going through pretty much the exact same process, except we're doing this all in one notebook with code, right? So here we can use the hardware module to actually look for available nodes. So we can just run this here. And specifically, we're going to be looking for this compute cascade lake R node type. And this is going to go ahead and run a lookup through OpenStack, see what nodes are available, and then it's going to print out this nice little table here for us with all the nodes that are currently ready to use. So lots of compute cascade lake R nodes are available, and we can just pick one of these specifically, or if we don't care, we just say, okay, great, there's a lot of nodes available, give me one of them. So now that's what we're going to do down here. So we're going to set up our lease using the lease module. We're going to create a lease object with the name of the lease and the duration. It's going to be 3 hours. We're going to add a specific node type. So this is going to be taking the first available node that was returned from this list up here. And then we're going to add a floating IP address to this, and we're going to submit it. And then this is going to go check for lease availability. If there's availability, it's going to set up the lease, and then it's going to come back and tell us once the lease is ready to use. So here, going to see a little bit of a progress bar here as we wait for it to set up. I'm probably not going to wait for all of this code to run because, as I mentioned, the bare metal images can take 10 to 20 minutes to start up. So I don't think we're going to want to sit around and wait for that. But moving on to the next code here. So, okay, so now we see our lease is now active, and now we're ready to go ahead and actually create our instance. We're going to do that using the server module here. So we're going to create a server object. We're going to give the server, we're going to name our instance. We're going to specify the reservation ID that we want it to use. So that's going to come from this reservation up here. And then we're going to tell it the specific image that we want to use for the lease. And then we can go ahead and run that. And again, it's going to show you kind of the same thing that you saw up here, except this is going to take much longer. You see we have this warning here. Typically takes 10 minutes for bare metal, but can take up to 20. And this is just going to run until the server becomes active. If it doesn't come active, it's going to throw me some error. If it does, it's going to come out with some error message that says, you know, your instance is now active. And then the rest of this code is going to be the fun stuff. So we now have our active lease. We're going to connect to it by associating our floating IP with the instance. Then we can run this check connectivity function to see if we can make the connection. And then once we have that connection established, this is where we can start running commands to execute things on our server. So using the instance we've created, we can tell it run this git clone command and then run this setup script. And that will then come back and output all of the output from the instance. And then here we can go ahead and run our experiment script using the same execute function. And that again will run this script. And then cool part is that we can actually take the data that we have gathered and we can create a bucket for it and go ahead and pull out that data from the bucket. And then we can actually go ahead and analyze the data right here in our notebook. And down here, you see some code to actually plot the data that we obtained from the experiment. So fortunately, I can't show you that cool stuff because we're still running this. It's still waiting to boot up. But maybe I can pause here and open it up for questions. And then we can see if maybe this finishes running shortly and I can show you the rest of this real quick. But I think that's most of it. So yeah, any questions from our attendees? Anybody? If you'd like to ask a question, you're welcome to either put something in the chat, or I believe we also can unmute folks. You can ask questions by live if you would prefer.
If I can start if people.
Sure, Bogdan, what do you have a question? I see a question from Ojas Gupta. There is, okay, so yes, we do have lots of documentation that you can look at. I'm sorry, I should have showed you this. So if you go back to the main Chameleon site, we have this Learn tab up here. There's a couple of important things. One is the FAQs. So if you're curious about like kind of general policy, what's allowed on the platform, what's not allowed, the frequently asked questions is a good place to go. This just has a lot of general information about, what is Chameleon? How are you supposed to acknowledge and cite Chameleon? How can you find help? Um, questions about project setup, security practices, etc. There's also some questions kind of about common questions that we get about, uh, the test bed and etc. So that's one place you can go for help. The other main place for documentation is going to be the Read the Docs site. So again, it's just going to Learn and then clicking on documentation. This is going to be the most comprehensive source that we have available for getting help. This has pretty much everything you could think of about the testbed, object store, working with containers, working with objects, using the CLI with all of this stuff. There's so much functionality. It's hard to go through all of it in one tutorial. But lots of information here. Step-by-step guides on how to do pretty much everything we just went through. I will also call out the Getting Started guide, which is I'll go ahead and put this one in the chat here so that Getting Started guide is a really good way to just kind of get basically what we did here, but just kind of going through it yourself and maybe more at your own pace. And it does also mentions all of the stuff with Python Chi and things like that. So it's a very comprehensive place to get help. And the final thing I'll mention is if you're still having trouble, or you still don't know what to do or where to go, one option is we have webinars, so you can go back and watch other webinars, but that may not be super helpful. The other option is you can go to the help desk and open a ticket. And so I already kind of showed you how to do that, but that's always a good option if you're still stuck and you can't find the answers you need from any of the publications. I should mention Tips and Tricks, another good place to come and check out stuff that we have. For example, building MPI clusters on Chameleon. This has like a whole kind of short walkthrough on like how you can set up an MPI cluster and the different resources we have available for doing that kind of thing. So these are tips and tricks. This category is particularly useful and is sometimes has the answers that you're looking for that you may not be able to find in our regular documentation.
Thanks, Mark. This really helps. Thank you.
Yeah.
Thanks. While other people are still thinking about their questions, I actually had a quick question. You mentioned in the beginning, Mark, that the easiest way is to use federated login. What happens if some committee members are from a university that is not part of Globus yet? Do they have to create an account through their Gmail account, for example? Or if I invite them to join the project with a Gmail account, would that be enough for them to log in? Like, would they have to request an account through Chameleon, or can I help them in any way to make this process smoother?
Yeah, so you can add users to projects before they have user accounts. What happens in that case is that an email will be sent to whatever email you used to add them, and then they'll basically just have a link from that email to log in, and it will just take them to through the regular login process. So at that point, then they would just have to select, log in through Google and then do that if they don't have access to the Globus auth.
Gotcha. So the kind of question for me is I can go ahead and whoever, wants to use or thinks you'll need Chameleon can they'll have a form and or maybe I'll just give access to everybody and then they can click on the link. Would that prompt them to log in, or would they have to do something else on their own independently?
Yeah, that should. So once you add them to the project, they should get an email, and the email should just basically say, you've been added to this project. Click here to access the project. And then when they click on that link, they'll have to log in. And I think, yes, it should automatically link them whatever you added at the beginning. So but if it does come up, so I may be wrong about that, and it may be that like if you send them an email to a different account and then they use a different account to log in, they might get some kind of issue. If that happens, then just add the email they used to register, and then everything should be fine.
Gotcha.
But yeah, for the most part, it should be fairly smooth. We don't usually run into those kinds of issues with adding new users to projects. So hopefully that should be, pretty straightforward.
Gotcha. Thank you. I think we have one more question.
Oh.
Mahbub.
Can you run them in the background? So I don't know if you can necessarily close the tab, but for instance, I mean, this one was running while we were just talking, and I think maybe your question is like, is there a way for me to just kind of run this stuff and then walk away and not worry about it? I mean, yes, I think it just depends on, I think if you're in the Jupyter environment, so I would say that, yeah, I think if you are running a notebook, if you just kind of shut it down unexpectedly, it would probably still run whatever it communicated to the host, because this is not running on the specific instance, right? So like this right here is running in a separate environment, and then I'm connecting to the host from that environment and doing stuff on the host. So anything that you start running on the host is going to run on that separately, right? So even if you start your experiment and it's running on your host and then you close your notebook or whatever, your experiment's still going to be running on the hardware you're using, even if this particular environment is still not active, if that makes sense.
Yeah, thank you. Thank you for the answer.
But yes, these environments are, so there's a couple different things here. One is I'm starting this environment from an artifact, so I'm already kind of like being specific about this, which artifact I'm going to interact with. If you want to just do something like you want to just start from scratch, let's say, or you want to let's say you want to start from this notebook, but then you want to build on top of it and use it for something else. you can also just go to the Jupyter interface itself, and this is associated with your account. So all of this is going to be like persistent to your account. So if you want to actually develop a project for in this environment and then upload it to Trovi, probably the best place to start would be go to the actual like Jupyter integration and start from there. And here you'll be able to make directories that will then be persistent. You can put files in them, and the files will stay there. And when you come back, after being away for a while, they'll still be there. So I should mention that too. This is a persistent environment, so you can use it for like a workspace. And you won't necessarily lose things, but if you're going to start from the artifact, you might just want to make sure you transfer over the artifact over to like your main workplace so that you have your files here and you can access them. And I should mention too, so we have, I said there was a way to create artifacts pretty easily from here. So for instance, if I wanted to create an artifact, I don't know, let's pretend that this is an artifact that I want to upload. I can just right click on this folder here, and I can click this create new artifact version. And
So I'm not seeing anything on your screen.
oh, I'm sorry. Didn't have my screen shared. I am so sorry. Okay, I just went through, I started here. I said
It's okay.
Jupyter interface, and then Jupyter interface loaded, and then this is what you can see here. So these are like directories that I created a while ago that are still here. So I can actually, create a directory here and build a project. Once I have built the project, so what I was just showing you here is, so I have this folder, my Python G tutorial. It has a notebook in here. And then if I wanted to upload this to Trovi, what I can do from here is I can just right click this artifact and I can say create new artifact version. And then I can click this upload, and then it's just going to publish it on Trovi here. So this is a little bit not super informative example because this is an artifact that's already existing on Trovi, so I just updated the version. I didn't upload a new artifact. But yeah, like let's see. Apparently all these are artifacts already. But if I click on this edit artifact, oh wait, maybe yeah, here we go. So here, this is where I can actually add metadata for the artifact, description, long description. I can set the visibility, add authors, etc. And then once I save this, it will then get uploaded as a new artifact to the Trovi service that we're looking at. And if you make it public, then other people would be able to see your artifact, click on it. If they have an allocation on Chameleon, they could even launch your artifact and run it. So that's one option. The other option is you can also just use GitHub, create your GitHub repository, and then we do have a pretty simple way for folks to use GitHub to then import artifacts using GitHub as well. And this is all pretty straightforward for the most part. There's lots of other integrations that we offer for these kinds of publication things, like you can get a request a Zenodo DOI to be associated with the artifact and things like that. So again, lots of stuff in the documentation to look at more specifically.
Cool. Thank you, Mark. Any other questions? Questions about Chameleon, about the infrastructure, about Trovy, or even about the artifact evaluation process itself? Just feel free to unmute and or type the question in the chat. We'll hang around for a few more minutes if folks, have more questions. Yeah, but if not, obviously you could, like Mark mentioned, you can always go back and watch the webinar if you try out Trovy or Chameleon, and you find any kind of issue or you have more questions. There's another webinar happening in a week. You guys can definitely join that and ask your questions there. Soon we will have artifacts coming in so you guys can see how they look like a little bit and what are the requirements. And of course, we're always available on email. You can email us, you can email me, or you can email the generic AE committee email that is on the systems artifact website. Right. And with that, if there are no other questions, if you guys are good to go, then let's wrap things here. Let's thank Mark again for his help and his useful guidelines and advice. Let us know if you have further questions over email, and don't forget we have another webinar in about a week. So keep an eye for those out for those emails.
Yes, and I will as soon as I can, I'll share the recording of this with you, Bogdan, so you can send it to everyone. And I'll also share the slides so that people can look through the slides if they would like.
Yeah, sounds great. Again, thank you, Mark. Thank you for your help. Thank you for running this webinar. And yeah, see you in a couple of days.
Great. Thank you, Bogdan. Thanks, everyone.
Great. Thanks, everyone. Take care.